Hey everyone! Today we are diving deep into a technology that literally reshaped modern software, Docker. We're going to break down exactly what it is, how it works under the hood, and most importantly, where it stands in the wild world of tech in 2025. And honestly, that's not an exaggeration at all. Ever since it went open source way back in 2013, Docker has become an absolute cornerstone of how we build software. What it did was take this really complex, powerful idea, software containers, and make it so simple and user-friendly that everyone could finally use it. It completely changed the game.
So here's how we're going to break it all down. First, we'll look at the big problem that Docker solved in the first place. Then we'll get into the nitty-gritty of its core parts. After a peek under the hood, we'll see how it's actually used every day. And finally, we'll tackle the big debate for 2025, Docker versus its main rival, Podman.
Okay, let's start at the very beginning, because to really get why Docker is so important, you have to remember what life was like before it. The number one headache for developers was always the same. Hey, the code works on my machine. How do you make sure an app runs the same way when you move it from your laptop to a test server and then to production? Before Docker, the main solution was something called a virtual machine, or a VM. Now, picture this. A VM is like building an entire separate house for every single one of your apps. It has its own foundation, its own plumbing, its own operating system, the whole shebang. It works, but man, is it heavy and slow. Docker containers, they're completely different. They're more like secure private rooms inside the same house. They all share the main foundation, the host operating system's kernel, which makes them ridiculously lightweight and super fast to start up.
And this lightweight approach, it unlocks some incredible benefits. First, and this is the big one, portability. That classic, it works on my machine problem, gone. You package your app once and it just runs consistently, everywhere. They're also way faster and use way fewer resources than VMs. This efficiency means it's super easy to scale up by just spinning up more identical containers. And finally, you get security through isolation, keeping each app in its own little bubble, safe from everything else.
Okay, so we get why containers are so powerful, but how do you actually, build one? Well, that brings us to the three fundamental building blocks of the Docker universe: the Docker file, the image, and the container.
Everything, and I mean everything, starts with a simple text file called a Docker file. Just think of this as the recipe or the blueprint for your application. It's a list of instructions. From this base operating system, copy my application files into here, run this command to install my dependencies. It's a simple, human-readable script that defines your app's entire world. So you take that Docker file, you run a build command, and what you get is a Docker image. Now, the key words to pay attention to here are inert, immutable, and read-only. It's basically a frozen snapshot of your application and all its stuff. A great way to think about it is with a programming analogy. If a Docker image is a class,
Then a Docker container is an instance of that class. It's the live running version of the image. When you tell Docker to run an image, it creates a container, which is basically that read-only image with a thin, writable layer on top. That's where your app actually runs, and where any changes happen. And from one single image, you can stamp out hundreds of identical running containers.
so the whole workflow, which is what makes this so powerful, is this simple three-step dance. You write your blueprint to the Docker file, you build that into a frozen, shareable image, and then you run that image to launch as many live containers as you need. It's clean, it's simple, and it's repeatable. All right, we've covered the what, so now it's time for the how. How does Docker actually create these little isolated worlds that all share the same operating system kernel? The secret is a combination of some really clever Linux technologies and a smart architecture. I mean, this is the key question, right? It feels like magic, but it's really just a testament to the power that was already built into the Linux kernel and how the Docker platform was designed to take advantage of it.
The whole system has a few main players. First, there's the Docker client. That's just the command line tool you're typing into your terminal. That client talks to the Docker daemon, which is this background service that does all the heavy lifting, building images, running containers, managing everything. We already know about images, and a registry like Docker Hub is just a central warehouse for storing and sharing those images.
So what's the secret sauce the daemon is using? It really boils down to two core features of the Linux kernel: namespaces and control groups, or cgroups. Namespaces are what give you the isolation. They trick a container into thinking it has its own network, its own list of processes, its own file system. It's in its own little bubble. Cgroups, on the other hand, are like the resource police. They're what makes sure one greedy container can't eat up all the CPU and memory on the host machine.
Now, the Docker daemon doesn't do all this work by itself. It actually delegates. It uses a higher level runtime to manage the container's lifecycle, things like downloading the image and setting up networking. That tool then calls an even lower level tool which does the real grunt work of talking directly to the kernel to set up those namespaces and C groups. This layered approach is what makes the whole container ecosystem so flexible. All right, now that we've geeked out on the engine, let's zoom back out. How is all this tech actually being used by developers and companies in the real world? This is where you can really see Docker's impact.
You see it everywhere, but there are three huge use cases. First, CI/CD pipelines. Docker guarantees that the environment you build your code in, test it in, and deploy it in is exactly the same every single time. No more works on my machine surprises. Second, it is the absolute perfect tool for microservices, where you break a big application into tiny, independent services that you can scale and update on their own. And finally, for local development, tools like Docker Compose are a lifesaver, letting you spin up your entire application, your database, your API, your front end, with just one command.
Now, running a few containers on your laptop is one thing, but what about running thousands of them across a huge fleet of servers? Well, that's where you need something called container orchestration. Docker has its own tool called Swarm, but over the last few years, the entire industry has pretty much decided that Kubernetes is the king of managing containers at a massive scale.
And that brings us to our final and maybe most relevant section for today. See, Docker isn't the only game in town anymore. A really powerful alternative has popped up, and its name is Podman. Understanding how they're different is absolutely crucial if you're working in this space in 2025.
The single biggest difference, and you have to get this, is the architecture. Docker uses a central, always-running daemon process. Podman is daemonless. And that one change is what enables its biggest selling point. Podman is rootless by default, which is a huge win for security. It dramatically reduces the potential attack surface. This isn't just a feature checklist, it's a totally different philosophy. Docker is all about an integrated, smooth developer experience, while Podman is about security-first, modular design that plays really nicely with the industry-standard Kubernetes. So, with Podman and its rivals pushing this more secure, daemonless architecture, what is Docker doing? Are they just sitting back? No way! They're aiming to conquer the next massive frontier in software, artificial intelligence. And check this out. This shows their vision perfectly. They're creating a new tool called Docker Model Runner. The goal is to make all the nightmare complexity of setting up AI environments, managing all the different dependencies, drivers, GPU issues, just disappear. The dream is a single, simple command, Docker Model Run. And because they've added support for a technology called Vulkan, it works across a ton of different GPUs, not just NVIDIA, which could make local AI development way more accessible for everyone. So, where does all this leave us? Well, the container world is more exciting than ever. You've got the incredible momentum and ecosystem of Docker, which is now pushing hard into AI. But on the other side, you have the security-first, daemonless approach of rivals like Podman that is gaining a ton of traction. And that leaves us with this huge, fascinating question. Which model is going to win out? Or is the next big thing in containers going to be some kind of blend of both? That's what every developer is going to be watching very, very closely.